Okay, welcome everybody to week 7 of BeginnR. Today we're starting on joins and heat maps, which is going to be one of the more interesting topics that actually people use a ton for the C1. And we only have like this week and one more of content left, and then like our week 9 is like our final like how you can go on from here in R. So stay tuned for that. We're starting with announcements. So this is basically like giving you guys an idea of what you guys are going to be able to do after like the homework. The homework like guides you through like each step of how to like turn data from like a data set to this. It's super cool, and like for people who want to do like sort of stuff that does like mapping or like inequality data or that sort of stuff, I feel like it's a super nice way to portray that. And we also had a talk this week with Professor Roden from like Poli-Sci 1, or like he's an amazing politics professor here. And this professor works with like courts on like settling legal disputes and stuff, mostly in terms of like equity. And this professor like knows how to use like this sort of stuff, and he actually like presents like stuff that looks kind of like this in courts. And it seems to help people that are making these decisions in juries. So it is definitely an important skill to have. Okay, demo. So today we're starting with joins. The idea behind joins is basically, as the name suggests, joining two data sets based on a variable that we're interested in comparing. So let me just walk you guys through this. So in Tidyverse, the package that our join functions are in is called deep layer package. As long as you run library tidyverse, don't worry about that. There's several join functions, and each different join has a different purpose, but the overall process is as follows. So first you have two data sets with some variable or column that has unique values. So real life example, I have, for example, for the Texas one, I have one data set on the proportion of Hispanic inhabitants and another data set on like what the geographical location of each county is, right? So I want to join both. So in this case, I have a unifying variable, a variable that appears in both data sets. My variable will be like the county name, for example, or like the county ID, since like the data is segregated per county in one, and then the geographical data is also like segregated per county. So the county column, whichever I choose, is going to be my joining column. It might also be like your social security number if I'm talking about healthcare people, zip codes, etc. And it is really important that these values are unique, because if there are repeats, then the data is going to mess up. But otherwise, if there's like a unique like way of identifying a single variable that does not have repetition, that is what you're looking for. Okay, step 2, you join the two data frames by this value. So in this case, like the county, and you choose a join function that is appropriate to your outcome. For example, if your outcome is only including the unique values in the first data set or in the second, or including like all the values we're going to go into in a second. And then the result of doing that join is you get a single, is like you have two data sets, join them, you get a single one that contains the columns of both the new and the old data set, plus the column that you use, join them together, in this case, county. So left join is by and large the most common join function that you will use. And actually, I just want to cover them super quick, like the theory again. So imagine we have these two tables, these two data sets, X and Y. And basically we have these variables in common. We have 1 and 2, basically. So if we wanted to join these two, here I have like this is super easy to see, because we have a data set on the left, which is like the first one, the old one, and the data set on the right. So imagine here that I want to do, for example, an inner join, right? So the inner join is going to see, okay, imagine that this column that says 1, 2, 3 and 1, 2, 4 is like my uniquely identifying variable, the variable that I want to join by. So what R is going to do is it's going to like look for common values. In this case, 1 matches with 1 and 2 with 2, but 3 and 4 don't match because they're not the same. And it's going to join those two. Now, if I want to do an inner join, what inner join does is it matches pairs of observations whenever the keys are equal. So in this case, I'm only going to get a table that has 1 and 2 and like the values in X for 1 and 2. So X1 and X2 and then Y1 and Y2. I'm not going to get 3 or 4 because they don't match, but I would get these two at the top because they do match. So inner join takes this corresponding column in both and sees I'm only going to get the rows that appear in both data sets, right? not the other ones. Outer joins, I don't really think we should go over. Do they have left joins here? Otherwise, we can do, no, they don't. Okay, basically left join, I'm gonna use the example. Left join, for example, looks at the data set on the left, and it's gonna keep all the rows on this data set. So it will keep row 1, row 2, and row 3. And then it'll go to the data set on the right, so this one, and it says, okay, which ones on the right match with the data on the left? In this case, 1 and 2. So it's gonna have 1 and 2 which match, and then 3 which appeared on the left. It's called left join because it conserves all of the rows that appeared on the left, and then it adds the ones like as in like extra columns that match the one on the left. If I do right join, it will be the opposite. I get rows 1, 2, and 4, and then I get extra columns for 1 and 2 because those match. So basically, that is everything you need to know. You can do full join too. Full join like actually like keeps all the rows in both left and right. So I have 1, 2, 3, and 4. But I have like NA not available values for like 3 and then for 4 in terms of like X3 and Y3. Any questions about that in the chat, or just speak them out? Okay, as we said, left join is by and large the most common. Imagine, for example, that in this real life example, you're trying to, so you have on the left, you have your data on county proportion of Hispanic inhabitants per county in Texas. And on the right, imagine that you have like a data set that contains all of the geographic locations of every single county in the United States. Here you use a left join because you only want the rows on the left. You only want the rows in Texas. And then it's just going to match the rows in Texas on the right. And you're going to forget about like the rows in all the other states. So that is how a left join will be useful. Any questions about any of this at all? Okay, so as another example, let's look at 2 data sets, 2 tables that we want to put together. We have band members that has Mick, John, and Paul, and we have band instruments. Okay, in this case, we see that we have a column that is repeated and that is unique, which is named for both of these tables. So we probably use that column as a like column to join by. So here we want to see which player played in which band and what instrument they played. So let's use a join function to do that. So if we're doing band members and we're piping that to a left join, band members, since it goes to the left of the pipe, it is going to be the left data set. And then whatever is inside this first argument is going to be the data set on the right. If I just go to the help menu by pressing Fn F1 on the keyboard, I'm going to see that for left join, I have X, which is whatever I pipe in. Whatever I pipe in, as we mentioned, is always going to be the first argument, in this case X. So this is going to be the data set on the left. Then the first argument after the pipe is going to be Y, which is going to be the data set on the right. And then the by argument equals the name of the column. In this case, the column name is name within quotation marks. Always within quotation marks. If you don't write in the quotation marks, you're not going to get it. It's going to give you an error. So in this case, we would expect this join statement to keep all the rows on the left data sets of band members. So it will keep Mick, John, and Paul, and then it would try to join them to see matches with this second data set on the right. So it would match John. So we get like a guitar column for John. Paul is also there, so we get a bass column for Paul, but Keith is not there, so we would not get any extra rows. So let's try that out. Let's run that. And as we said, we got Mick, John, and Paul. We got the column band that was in the first data set, and then we got another column, which was the instrument they play, and we got an NA as we expected for Mick, because Mick doesn't match in the right hand side data frame, and we did get John and Paul. Questions? Okay, so for the second example, instead of using left join, we're using right join. What right join does is it's going to take whatever it has. So the first argument is actually going to be what is on the right. Sorry. First argument is always what goes on the left, and second argument is always what goes on the right. So let's just run this. So the rows that we're conserving here, John, Paul, and Keith, those rows are the ones for band instruments, which is our data set on the right. Right. So actually band instruments, which goes inside, is the Y argument. The Y argument is always the data frame on the right. And the X argument, which goes before the pipe, is always the row on the left. So what this is doing is, okay, it's saying band instruments, you're on the right, and it's the right join. We're keeping all of your 3 columns, John, Paul, and Keith. We're keeping all the instruments that they play, guitar, bass, and guitar. But then we're trying to match that with band members. So since there's no match for Keith, there's going to be an NA, but since there is one for John and Paul, we're going to get the value for that column. And then inner join just keeps the values present in both data sets. In this case, we only had John and Paul that were matches, and we're going to have their column information for those. If we wanted to keep all the rows, we do full join. As you see, since Mick doesn't have a match in the other data set, we're going to get NA for the instrument that they play, and Keith doesn't have a match, so they're going to get an NA for the band. Cool. Any questions before we move on to the second part? Okay, so recap, X or whatever the first argument is always going to be the left data set. Y is going to be the right. Depending on what type of join you use, you're going to get a different result. So be careful of which one is your left and your right data set, and be mindful of what you want to do with that. Okay, part 2, pivoting. So if we want, for example, our data to be for example, sideways, or if we have a table like this and we want to turn it around, that will be pivoting. So if we want our columns to use rows or vice versa, this is a really common problem, and it's really important to know how to pivot. So let's check out the documentation for pivot longer by typing out a question mark before pivot longer. So at the bottom right here in the help menu, I'm getting that it lengthens the data by increasing the number of rows and decreasing the number of columns. So by lengthening, they mean that if you have data like this, they're gonna put it around like this. So it takes the first argument, which is the data, which I could pipe into pivot longer. And then it takes several others that we're gonna see in just a second. Is this transposed from matrices? Yes, I think so, yeah. And then for pivot wider, we'll just go back to the help menu when we use them. For pivot wider, it changes the data from long to wide. And yeah, it increases the number of columns and decreases the number of rows. And the inverse of pivot wider is pivot longer. So they're the opposite of each other. Okay, so we have this billboard data set. Let me just press this button with the arrow to expand this in a new side. So we have all these columns that say WK8, which stands for week, WK whatever, until all of these different columns say week, and we have a very wide data set that we want to put into a very long one to avoid having all those different columns, one column for each week. So in this case, since we want to lengthen it, we're going to do pivot longer. So let's just work through the pivot longer. Let's just work through the documentation and see what each argument stands for. As you can see here, all of these are the arguments. And then if you scroll down, you're going to get what each stands for. So the first argument is going to be data. Since we're passing it in with a pipe, that's going to be our billboard tibble. So that's a data argument. The second one is columns. What does columns mean? Those are the columns to pivot into longer formats. So in this case, we want to get rid of all the columns that start with week something and turn them into one single column that says week, and we all the rows are a different week number. So we want to pivot all the columns that start with WK. That's what the sort with function does. And then names to, it says a string specifying the name of the column to create from the data stored in the column names. So we want this new column that we create to be called week. And then names prefix is whatever you want to use to remove matching text. So in this case, for example, for week 14, we want a column that only has a weeks, and we want to have 1, 2, 3, 4, 5 to 14, for example. So we just want a row to say 14. So we set the prefix to WK, so it gets rid of that WK right here before the 14. And our rows are just going to be as 1, 2, 3, 4, 5 without the WK. And then the values to argument, if I scroll down, means a string specifying the name of the column to create from the data stored in the cell value. So we're creating an extra column that is going to be called the rank. That is what values to specifies. And basically that is going to be these values here, 87 is the rank of that song in that week. So let's just do that. And let's just print it out. Okay, so we conserved artists in track. Those columns are conserved. Date entered too. And then instead of having a separate column for each week, and the rank in that corresponding week, we have a column called week. So that's in names too, and the columns in argument like practice. And then we eliminated the WK prefix from all these different columns. So we only have like a number 1, 2, 3, 4, 5, whatever. And then we created a new column called rank. Here we go. And we draw, this means values drop NA means like drop all the values that have an NA or not available, which is set to true. So we won't have any rank that adds a value of NA. We're just gonna get rid of those columns. Cool. Any questions up to this point? I know it's a little bit like dizzying. There's one in the chat. So it removed all the columns, start with week, right? So it removed all those columns, like week 1, week 2, week 3, week 4. And instead of all of those, it created a single one called the week. And if it said like week 8, WK18, it's just going to say 18 in the row. WK19 is just going to say 19 in the row. Same for all of those. Yeah, and it made them go into a week. And this prefix, names prefix thing was used to eliminate the WK before each of those. Cool. Any other questions? Okay, let us check out pivot wider. Let's just run that. Okay, so this data frame that is a long data frame DF. We're passing in as a data argument to pivot wider. Let's just. Okay. Oh yeah, there's a question. What does the names prefix do again? So the names prefix, so the columns that we're selecting here are all those start with WK, right? You want to get rid of all the columns that start with WK, conserve the rest. What the names prefix does is it's asking you, okay, all the columns that start with WK, do you want to get rid of anything? Yes, you want to get rid of the part that says WK, and just like conserve the number of the week. So like 1, 2, 3, 4, whatever. So that is like the 1, 2, 3, 4 that we're getting right here under the week column. Okay, pivot wider. So we pass in the data frame as a data argument. And names from says her argument is describing which column to get the name of the output name. So in this case, we are getting the column week and we're reversing this. So we're creating another thing that says like week 1, week 2, back again. So we're getting all of our column names are coming from this week column before. And the values that we're getting for the rows are coming from the column that we called rank, right? So like 67 in week 18 would change to a column that says week 18 and the value for the row is 67. And then names prefix here will be, what do we want to add? So like, okay, you got like 67 for the week or like 18 for the week. Do you want to add any prefix to that column name? So there's going to be a column that says 18. Do you want to add any prefix? Yes, we want to add a prefix called week under dash or whatever, underscore. So it's going to say week 18 instead of just 18, as you see here. Any questions? Let's see. Okay, great. Cool. If there's any, just ask. What's the difference between our original Billboard data set and the new table we got from Pivot Wider? Well, one that comes to mind is first that the weeks are named differently. There's an underscore, there wasn't one, but that's because we chose to put an underscore. The second one is the number of NAs that are there. Remember that we dropped the NAs for the rank, and actually they're here. They are here. They do appear. But yeah, otherwise it's like a reverse of what Pivot Long did. Question: what happened to rank? Okay, so the values under rank, since they're in a column and we're using pivot wider, they turn to like rows, like row it's like values for each of those. So for example, and under week 20, so instead of having this column that says week, we have a column that says week underscore 20 here. And then instead of this column that says rank, which got deleted, we for whatever song that was in week 20, we get the rank of that song, and that goes inside the rows for this column. And I think there's one more. How does it know how to split up the data? Is it because different weeks share the same artist or song title? Right. So it is keeping, like, it does know that, like, Some values are for like Tupac and Baby Don't Cry. Um, so those are going to get conserved. The only thing that is changing here is like whether the rest of the values appear as columns or if they appear as rows. But otherwise, they're going to remain the same. Yep. Okay. That's it for the demo. Uh, we'll just go into breakout rooms then.